So for this question, we're doing the same thing. We're trying to determine the equation of an ellipse, but this time we have the foci and we know the length of the major axis. Now remember, the length of the major axis is always equal to 2a, so we'll start out by setting 2a equal to 30. Then we'll need to solve for a, so we'll divide by 2. A will be 15, and then we will square a to get 225. So we already know what a squared is in our equation. Remember, we need 3 pieces of information. We need to know the center, which is hk. We need to know the value of a squared, and we need to know the value of b squared. Now the foci is located at 19.3 and -7.3. So 19.3, -7.3. As we can see, the x's are the ones that are changing. So because the x's are the ones that are changing, this is going to be a horizontal ellipse, which means that the a squared is going to go underneath our x's. Now remember, the length of the foci is equal to 2c. So the distance between these two focal points is going to be 26. So from positive 19 all the way down to -7 is 26. So we'll divide by 2. C will be 13. So then c squared will be 169. In order to determine what our b squared is, we will need to take c squared and a squared and plug it into our formula. C squared equals a squared minus b squared. So that'd be 169 equals 225 minus b squared. We will subtract 169 from 225, and we will get -56 equals a negative b squared. We have to make both of these positive, so b squared is going to be 56. To find the center, we're only given the coordinates of the foci, but the center is always located in the middle between the two vertices, between the covertices, as well as the foci. So we're basically going to find the midpoint of the foci. Remember, finding midpoints, that's the sum of your x's divided by 2, and then the sum of your y's divided by 2. So then that's going to be 12 over 2, which is 6. That's going to be 6 over 2, which is just 3. So our center is at 6, 3. And that is our equation of our ellipse. 2 more examples. One more of writing the equation of an ellipse, the other one talking about eccentricity. We have the vertices here, and we have the length of the minor axis. I want you guys to try to determine this one on your own. So pause the video, and then press play when you're ready to see the answer. This is the equation that you should have gotten for this one. Since the vertices, the y's change, we know that's going to be a vertical ellipse, which means our a squared, which was 36, is going to go underneath our y's, and then our b, since our minor length was a length of 10, we set that equal to 2b. We solve to get b squared is 25. Now, eccentricity is basically tells you how stretched out the ellipse is. It's a number that is found by doing this formula over here, E equals C divided by A. So when you find the A in your equation and then you do the formula to find your C, you divide them and you get your eccentricity. It will always be a number in between 0 and 1, never negative. And if the number is closer to 0, that means it's more circular. It's more likely to look more like a circle than an actual oval. But if it's closer to 1, it's going to look more oval. So to determine the eccentricity of this particular ellipse, first off, just based off of our denominators, we know that this is going to be a horizontal ellipse because our larger denominator is underneath our x's, which means that a squared is going to be 100, and then b squared is going to be 9. We need to know the value of c, so we're going to use the formula c squared equals a squared minus b squared. That's 100 minus 9. C squared is 91. So then C is the square root of 91. The value of A is going to be the square root of 100, which is 10. So our eccentricity is going to be the square root of 91 divided by 10. And whatever that decimal is in your calculator, that is going to be your eccentricity. So the square root of 91 divided by 10 is going to be 0.954. So since it's close to 1, this is actually going to be an ellipse that's a little bit more oval.